So the next topic we're going to look at here is I wanted to go a little bit into a little more detail into our actual control structure. And looking at the interactions of the PLC and how we basically sense voltages and currents, how we regulate the frequency, how we control our various items, whether it be the diesel engine or the flywheel extraction of energy. So this gives a little bit of a pictorial representation of what we're looking at here as far as how our system controls itself. If you look at our unit control panel, which is the main control panel, it contains our HMI. That's typically where you're going to be when you're operating the system, when you're turning it on or going to bypass. Within that cabinet, we have a number of devices, one of which is our actual PLC, which controls the system. And obviously the PLC is the brains of the system, right? It's basically the unit that's commanding things to happen, whether it be a breaker operation or a diesel operation or any other control function. But also in that UCP panel is a device that we call our digital controller, which I like to think of as the heart of the system. So the PLC and the Dicon controller, the digital controller, kind of work together to control the system. And the Dicon itself has a number of different functions, I would say. One is it's a protective device. It does have certain protections inherent or designed into the unit itself. Things like overcurrent, undercurrent, reverse power. These are protections that are built into the Dicon that form a part of what it does. It's also a monitoring device or a metering device because it's also what is actively looking at your voltages, your currents. It's looking at your speeds for your diesel and your flywheel. All these measurements are taken by the Dicon. And then your Dicon is also, in some instances, a controller as well. Okay, so it's kind of the go-between between the PLC and the devices that are being controlled by the Hitec system. Okay, so the Dicon communicates with the PLC. Let's first look at all the metering that it will do. So I mentioned earlier that we're monitoring the mains voltage and frequency, all three phases. We're also monitoring mains current as well. So that is all coming directly from CTs or PTs directly into the Dicon itself. But not only for mains monitoring, but it also monitors the load, voltage and current, all three phases. And it's monitoring also voltage and current from the alternator itself up through that choke tap. Okay, so there's actually three locations that we monitor voltage and frequency: input, output, and right out of the alternator. Okay, so all of these measurements are going directly into the Dicon, so it's collecting that information. It's collecting voltage, frequency, current information, and then it's relaying that to the UCP. It's also looking at your speed of your diesel, and it's looking at your speed of the flywheel. Okay, so that information also goes directly into the Dicon, and then it relays that to the PLC. Okay, so it's collecting information as part of its metering function and relaying that information to the PLC. But it's also taking commands from the PLC and then directing that to control the various devices for the system as well. So it has outputs as well so that it can control the diesel. And it will actually actively control the output of the diesel as far as how much power it has to deliver, for the load, or for, as we mentioned, the ULT function. It controls how much power is actively put back into the utility for the ULT mode. So the Dicon is actually sending the command to the diesel. It actually has throttle command of the diesel to tell the diesel to run at a certain speed to output a certain amount of power, either for the load or for ULT mode. And it does this by way of communicating directly with the ECM of the engine. So the engine has its own electronic control module. And there's a particular input to that ECM, which is remote throttle input. And so that is what the diesel is using, that remote throttle input, so that it can actually control the power output of the diesel. It's when that signal is taken away completely, that's when the diesel runs at 1750 RPM, or at idle speed. Because when we remove that command from the Dicon to the engine, it will then start to run at its own internal ECM set speed for idle, which is 1750. That's actually set in the ECM. Okay, that's not set in our PLC. So when we take away the throttle, when we put the throttle down to 0, that's when the diesel runs at 1750. Okay, it's its own internal setting for idle. But when we activate that output, that's when the diesel jumps up to 1800 RPM and starts to output power. Okay, and that's actually done through a PWM signal that comes from our Dicon. Our Dicon outputs are all pulse width modulated signals for controlling the diesel and other things as well. So the Dicon also controls the amount of power that's put in for the DC injection for the flywheel to grab onto it to extract the energy from it. Okay, so that's another PWM signal that comes out of the Dicon that goes to our exciter, our DC exciter of the chem, to control the amount of power extraction from the flywheel. We also have an input from our Dicon into the alternator AVR, because it can also help control voltage as well. Now the AVR of the alternator is more or less kind of a dumb device. All it does really is it takes a feedback of voltage from the output of the choke into the AVR, and it regulates the output voltage at a set level depending on that feedback. So we set the AVR voltage, for example, at 4160 for your site, and that's what it tries to regulate to. But our Dicon can also influence that a little bit, because we have an extra input into our AVR. So the Dicon can actually raise and lower voltage as well. And we do that for certain functions like paralleling, for load sharing, for K-bar sharing, for paralleling machines. And I think we can also use that because sometimes the utility voltage may not be right at 4160. Sometimes it'll be a little bit lower. Sometimes it might be a little bit higher. I've noticed on your site, I think during testing, last week, we come in the morning and your voltage on your utility would be 4100 maybe, and then later in the day it'd jump up to 4180 or something. So you must have some loads that come on or off that affect your voltage. But I noticed that sometimes it'll vary throughout the day. And what our Dicon can actually do is, if that voltage, that mains voltage comes down a little bit, it can actually lower voltage so that we kind of match the utility voltage a little bit better, rather than staying at a constant 4160. Because one thing that will actually happen if we're running at a reduced load voltage is if we stay at 4160 on the output and your load voltage is at a lower level, 5% lower or whatever, we'll actually export some bars back into the utility because our voltage is higher. And that's not necessarily a bad thing, but it does provide some extra current back into the utility, which is reactive current, that we can mitigate if we lower our voltage a little bit on the output side. So our Dicon can kind of help in that situation as well, because we can influence the voltage just a little bit by giving a little extra to the AVR command, for example. Okay, but the Dicon again has output control of the diesel, the flywheel, and to a lesser extent the AVR as well. And so that's part of its controlling function. And then of course protections. Now we'll go down there eventually and we'll look through all the panels, and I'll show you the Dicon. We'll open the door and you'll be able to see the device. It also has some helpful indicators on it, which you can't see here because it's too blurry, but there are LED indications on the Dicon that give you some hints as far as to what it's actually seeing and doing. For example, there are lights that indicate mains voltage and mains frequency, whether it's in or out of specification. So it's a green light. It's very, you know, if the mains voltage light is lit, you know that the mains voltage is good. Same with frequency. It's got lights for output as well. It's got lights for synchronization. So you can actually look at the Dicon and you can tell right away, is it synchronous to mains? Let's say it's coming back to a, you know, after an outage. You can see where it's actively synchronizing the mains and it's in sync. So again, it's a kind of a helpful thing to look at if you know what to look for, and you can get some clues from what the Dicon is seeing just based on those indications on the front of the device. Okay, and we'll go through those. I'll show you those when we take our walkthroughs. The Dicon itself is a Mark II variant. It also has the ability to record logs from the system. So this is separate from our remote monitoring, but the Dicon itself can store certain amounts of information. It can log certain failures and utility outages, and we can extract information from it, you know, for troubleshooting purposes. You know, our service personnel can do that. So it also helps and records some log information as well. Hitec developed this device. It's purely Hitec's design, proprietary, and it's a very nice unit. It's what I call the heart of the system, but it communicates with the PLC to, you know, deliver all these functions for the Hitec system. Okay. Also, it's a very easy plug and play item, and it basically it's the same unit we use on all our machines. It's just a matter of settings file that gets loaded into it that makes it site specific, you know, for whatever the design the customer has. Oh yeah, and it's also a synchronizer. Obviously, it helps to synchronize the diesel with the utility, so it has a synchronizing function as well. If it were a parallel system, it also handled the synchronization to other units as well. So it can synchronize at the input and at the output. And it has a few other features which you're not using for your particular site because you only have one unit, but there's a lot of other capabilities that are involved here with the Dicon system. So, but it's a very nice system.